Hey everyone, I hope you're doing well today. In this video, I'm going to be talking about exponents and radicals. Let's start by looking at some powers with natural number exponents like 1, 2, 3, and 4. 3 to the first power is really just 1, 3. 3 to the second power is 3 times 3. 3 to the third power is 3 times 3 times 3. And 3 to the fourth power is 4 of those altogether. And when you're looking for the values of each of these, this first one is just 3. This next one is 3 times bigger, which is 9. Down here, this is going to be 27. And when you multiply 4 3's together, that's going to be 81. So it looks like while raising a 3 to natural number exponents, it gets larger. What happens when we raise it to numbers that are integers and we actually go into the negatives? 3 to the 0th power is just equal to 1 since we have 0 of these 3's. And remember, anything to the 0th power is equal to 1. And while you might think that 3 to the negative first power is a negative value, it's actually just a reciprocal. It's just 1 over 3 to the first power. For 3 to the negative second power, this is going to be 1 over 3 to the positive second power. And for 3 to the negative third power, that's going to be 1 over 3 to the positive third power. So that means the value of 3 to the 0th power is just equal to 1. 3 to the negative first power is equal to 1/3. 3 to the negative second power is equal to 1/9. And 3 to the negative third power is equal to 1 over 27. Now let's put these together to make sure we understand why this makes sense. So I'm just going to put in some powers here of -2, -1, 0, 1, and 2. And starting with our positive exponents, 3 squared is 9, 3 to the first power is equal to 3, 3 to the 0th power is 1, 3 to the negative first power is 1/3, and 3 to the negative second power is 1/9. The important thing to notice here is that when you keep increasing the exponent by 1, we actually get 3 times bigger. This is increasing exponentially. And another way you can think about it is as you decrease the exponent by 1 each time, we actually get 1/3 of the value. While we can say we're dividing by 3, we can say we're multiplying by 1/3. Now let's make sure this makes sense with some other types of bases, like 10. So we have -2, -1, 0, 1, and 2 as our exponents. And let's see what these are equal to. Well, 10 to the second power, we know that's just 100, or 10 times 10. 10 to the first power, that's just 110, or 10. And as these are being multiplied by 1/10, or getting 10 times smaller, the only logical number for this to be is going to be 1. This over here, 10 to the negative first power, that's equal to 1/10. And 10 to the negative second power will be 1 over 10 squared, or 1/100th. So hopefully you can see here that as we decrease the power by 1 each time, we actually get 10 times smaller, because that's our base of the exponent, or base of the power. 10 is actually a good example to look at, because if you look at this 2 here, that represents maybe 2 zeros. The 1 is 1 0. The 0 represents that we have no zeros here. And as we keep going down, then it flips down to the bottom, which is the reciprocal. Now let's take a look when our base is 2. So we have 2 to the -2, 2 to the negative first, 2 to the 0, 2 to the first, and 2 to the positive 2. Starting with the positive exponents, because it's a little bit easier, this will be 4. This is equal to 2. This must be 1. This is our reciprocal of 1/2. And this right here is going to be 1/4. And here you can see that as we increase the power by 1 each time, we're actually doubling the value of the power. And so we can generalize this rule with a base of x here. As long as x isn't equal to 0, we're going to have this equal 1 over x squared for any value of x besides 0. Then we'll have 1 over x. Then over here, this is just going to be 1 again. X to the first power is x, and x to the second power is equal to x squared. As we increase the value of the exponent by 1, the value of the power becomes x times bigger. As we decrease the exponent by 1 each time, you can see that we're actually taking the value and dividing it by x. And so that brings us to rational exponents. We know 4 to the 0th power is already equal to 1, and we know that 4 to the first power is equal to 4. So what's going to happen when we raise this 4 to the 1/2 power? What's that equal to? Well, it turns out that's equal to 2. Let's see if you can come up with a rule or a pattern based on a few more examples here. So here we have 9 to the 0th power, 9 to the 1/2 power, and 9 to the first power. So we already know that 9 to the 0th power is equal to 1 because anything to the 0th power is equal to 1, and we know 9 to the first power is equal to 9. Think about what this 9 to the 1/2 power should be equal to. If you were thinking about 3, then you're correct. Now let's try it with a base of 16. So we have 16 to the 0th power, 16 to the 1/2 power, and 16 to the first power. As we know, 16 to the 0th power is equal to 1, and 16 to the first power is just equal to 16. What do you think 16 to the 1/2 power is equal to? If you were thinking 4, then you're absolutely right. Here's one more with a base of 25. Let's raise it to the same powers here and think about what these could be. 25 to the 0th power is equal to 1, and 25 to the 1st power is equal to 25. This 25 to the 1/2 power is equal to 5. Hopefully by looking at these examples, you can actually see a pattern arising when you raise things to the 1/2 power. It turns out that when you're raising a number to the 1/2 power, you're just taking the square root of that value. 4 to the 1/2 power is just the square root of 4, and we typically don't write that little 2 there as our index. We can just write the square root of 4. 9 to the 1/2 power is the same thing as this little 2 as an index of this 9, which is really just the square root of 9. 16 to the 1/2 power, it has an index of 2 here and a base of 16. That's just really the square root of 16. And 25 to the 1/2 power has a little 2 here with a 25 as the base. And over here we're going to have, this is really just the square root of 25. Now 4 to the 1/2 power can be equal to plus or minus 2. 9 to the 1/2 power is equal to plus or minus 3. 16 to the 1/2 power is equal to plus or minus 4. And 25 to the 1/2 power is equal to plus or minus 5. Based on all those examples of raising some number to the 1/2 power, do you think you can figure out what each of these values raised to the 1/3 power is equal to? We can rewrite 8 to the 1/3 power as the cube root of 8. This 27 to the 1/3 power is really just the cube root of 27. 64 to the 1/3 power is the cube root of 64. And 125 to the 1/3 power is the cube root of 125. While you could have a positive or negative value when you take the square root, when you take the cube root of this 8, we can only have positive 2. If you think it could be negative 2, multiplying negative 2 times negative 2 times negative 2, we'll get a negative 8. So you can see that's not going to work when we have an odd number in the denominator. For the cube root of 27, we're just going to have positive 3. For the cube root of 64, we're just going to have positive 4. And the cube root of 125 is just positive 5. We can then generalize that when you raise something to a fractional exponent and the denominator is even, you could have a plus or minus answer. And when you raise something to a fractional exponent that has an odd denominator, you will only have one answer. Now let's try to understand powers that have fractional exponents, but the numerator changes. Let's start with the easiest one to understand here, which is 16 to the 4/4 power. 4/4 is just equal to 1, so we can write 16 to the 1st power. This is just equal to 16. The next easiest one to understand here is hopefully the 16 to the 2/4 power, because 2/4 just simplifies down to 1/2. A moment ago, we talked about how 16 to the 1/2 power would really just mean the square root of 16, and this is going to be equal to 4. Now looking at the 16 to the 1/4 power, remember the denominator will tell us our index, so this means the 4th root of 16. So you need to think to yourself, what number multiplied by itself 4 times equals 16? Or what number to the 4th power equals 16? If you were thinking about the number 2, you're correct. 2 to the 4th power is equal to 16, so 16 to the 1/4 power is equal to 2. Here's the example that's a little bit trickier, the 16 to the 3/4 power. One way we could look at this is we could write 16 to the 1/4 power, then just raise this to the 3rd power. Knowing your power of a power property, we can multiply the exponents together and multiply 1/4 by 3 to get 3/4. Assuming that's true, we can say that this is the 4th root of 16, like we did earlier, and then raise this to the 3rd power. We know the 4th root of 16, or the quartic root of 16, is equal to 2, so this is equal to 2 to the 3rd power, or 2 cubed, and this is equal to 8. At this point, it's a good time to realize that this 2 is just equal to 2 to the 1st power, this 4 is equal to 2 to the 2nd power, 8 over here is equal to 2 to the 3rd power, and 16 is equal to 2 to the 4th power. If we look at this from a slightly different perspective, we can write the prime factorization and say that 16 is equal to 2 times 2 times 2 times 2. By looking at just one of them, we're saying that this is really 16 to the 1/4 power. By looking at two of them combined, this is half of them, and we can say 16 to the 2/4 power. Looking at three of them, we can say 16 to the 3/4 power. And looking at all four of them, we can say that we have 16 to the 4/4 power, or all four pieces, which makes 16. Let's take a look at one more example where we have a base of 81. I think the easiest one to start with is this 81 to the 4/4 power, since 4/4 is just equal to 1. While we could just simplify the exponent, let's try to think about this on a higher level here. We can write that this is 81 to the 1/4 power raised to the 4th power. Remember, when we have exponents next to each other, we can just multiply them, so 4 times 1/4 is still 4/4. As we've been practicing, 81 to the 1/4 power just means the quartic root of 81, or the fourth root of 81, and that's going to be raised to the 4th power. Since 81 has a perfect fourth root, the fourth root of 81 is 3, and you can check that since 3 times 3 times 3 times 3 is equal to 81. And 3 to the 4th power does get you back to equaling 81. I think the next one we should look at is this 81 to the 2/4 power, so we can separate that and write 81 to the 1/4 power, but raise that to the 2nd power. Again, if we simplify the rational exponents, these would be easier, but I'm trying to write these out so you can see how they're related to radicals. This will be the fourth root of 81, and that will be raised to the 2nd power. So the fourth root of 81 we said was 3, and 3 to the 2nd power is equal to 9. That should make sense because if we simplify 2/4 down to equaling 1/2, then 81 to the 1/2 power would just be the square root, and that is equal to 9. Up top here, we have 81 to the 1/4 power. This should be easier just because it has a numerator of 1, so this is just the fourth root of 81, which we've done a few times here. And we can say that this is just going to be equal to 3. If you're wondering where the numerator is, we could technically just raise this to the 1st power, and that way we get the same thing. Now let's look at this 81 to the 3/4 power. Again, let's rewrite it as 81 to the 1/4 power, but then raise it to the 3rd power. Okay, so 81 to the 1/4 power, that's really just the fourth root of 81, and we can raise that to the 3rd power. So the fourth root of 81, as we've done a few times now, is equal to 3. And 3 to the 3rd power, that's going to equal 27. Looking at this 81 to the 5/4 power, we can separate this and write 81 to the 1/4 power, but then raise that to the 5th power. That's really just going to say we have the fourth root of 81 raised to the 5th power. And the fourth root of 81 is equal to 3, so 3 to the 5th power is just going to equal 81 times 3, and I think that's 243. And finally, for this 81 to the 6/4 power, that's really just the same thing as 3/2, but I'm just going to write it out long ways here. So we have 81 to the 1/4 power and raise that to the 6th power. Now that's really just the fourth root of 81. Hopefully you're seeing a pattern here. And raising that to the 6th power, the fourth root of 81 is 3, and 3 to the 6th power is going to equal, well, we already know 3 to the 5th power is 243, so multiplying 243 by 3, we should get 729. Let's try to see why this makes sense one more time. If we have the number 81, and 81 is equal to 3 times 3 times 3 times 3, we can see that we need to multiply 4 of these 3's together to make 81. If we don't have all 4 of them, we're going to get a value less than 81. And if we have more than 4 of them, we'll get a value greater than 81. Each of these 3's really represents a fourth root of the 81. Okay, so 1/4 each. And if you happen to go past having 4 of them, just say like you have 5 or 6 of them, then we really say that this is going to be another 1/4 and another 1/4. Okay, so the way we can think about this exponentially is that 81 to the 1/4 power is just 3, 81 to the 2/4 power is 9, 81 to the 3/4 power is 27, 81 to the 4/4 power is 81 itself, 81 to the 5/4 power is going to equal that 243, and 81 to the 6/4 power is going to equal 729. I hope you found this video helpful in understanding how exponents and radicals are related to each other. If you'd like to see a follow-up video on some practice problems, let me know in the comment section below and I'll try to work on that. As always, keep up the good work and I'll see you in the next one.